So in this presentation I will talk about AllegroCache, Franz's new fully persistent common Lisp object system. Now for Lisp people looking at this presentation, it might not give you enough information, so that's why on our website you also will find many different demos of how to use AllegroCache. But for this presentation we just want to give you some general background about what AllegroCache is and why we did this whole object-oriented database. So first, why did Franz create a new database? If you look at the numbers, you see that about 90% of all the IT money in the world for databases go basically to enterprise applications. And to some extent our customers are most of the time not in enterprise and applications, because our customers are most of the time in all the other applications. So if you look where our customers are and where 90% of all the interesting problems are that do not fit in relational databases, then you just go to our customers. Yeah, we have customers in the energy market, financial market, life sciences, telcos, government, media and energy. And all these customers complain to us that what they try to do just does not fit in a relational database. Now why is that? The reason is that if you look closely at their applications, you see that their data is best described as complex graphs or pointer spaces, and that these graphs are many times larger than memory. Yes, so you easily could have hundreds or 100 millions or billions of objects that you want to do some interesting search over. And what you especially see with these customers is that their operations cannot be captured in set operations. Yeah, their operations are much better described as graph search or complex queries or inferencing or reasoning. If you also look at the customers, you see that these customers work with very heterogeneous data. So they have these objects, for example in the bioinformatics area, where the objects are variable size all the time, and even the slots of the objects, or in relational database terms the columns of the tables, are highly unpredictable. So the uses or the problems they have require that it's very easy to add a new slot to an object, and relational databases, especially when you get into the high numbers, just make that very difficult. And what you also see is that our customers work with objects that change all the time. And I mean, if you try to do a change of tables in a relational database, just hard. So that is why our customers have many times a problem with using a relational database, particularly for their type of problems. Okay, one thing I want to stress is that AllegroCache is not a relational database. It's not a replacement for Oracle or MySQL when you talk about enterprise problems. Relational databases and SQLs really have their place. For example, they are perfect in the enterprise when transactional safety is of the utmost importance, when you need a certain level of standardization, and when your operations are mainly set operations. If you have tables that are very regular but where you have really millions and millions of rows, and where you do joins over multiple sets, then relational databases are just optimized for that particular thing. And relational databases, and especially then SQL, are also very fit for the enterprise, because it's relatively easy to find programmers that know how to do SQL. Yes, so there's a perfect spot for relational databases and SQL. And if you have a problem that better fits into a relational database, we just encourage our customers to use just a relational database, because we at Franz sell very efficient direct interfaces to MySQL and Oracle. For Oracle we even provide both a blocking and a non-blocking mode, and we have ODBC to all other databases. Yeah? So if your problem fits in a relational database, please use a relational database and use our normal tools to interface to these databases. But let me go back to one slide I showed you earlier. So I discussed why relational databases and SQL are in trouble for certain types of problems. Now, what programmers do that still try to get all the data in the relational database is that they write their own object relational mapping. And I think many people that will look at this presentation or listen to this presentation have created one of these object relational mappings themselves. So what you do as a programmer is that you, in your programming language, you create classes that reflect the relational database schemas. Then you as a programmer have to worry about how to marshal the data in your database into objects. Then because you had a particular problem where you wanted kind of a model of objects on top of the relational database, you now have to worry about, okay, how will objects reference other objects, and what happens if I, for example, kill an object that they point to? What will happen in the relational database if in my memory I kill this model? What will happen with all the pointers to this particular object? So that's one difficulty that you have when you write your own object relational mapping. And then once you've got everything in memory, then you have to write a layer to make it easy to simulate what I call pointer chasing or graph handling. And then while doing that, you will of course modify some of your objects, and now you have to worry about, okay, how do I lock my objects and how do I keep all my objects consistent, and which objects did I change, because finally you want to write your modified objects back to your database. So then you have to worry, okay, how do I marshal my objects back? Do I marshal all the slots? Do I want to change only certain columns in the database? And your biggest problem is if you change the schema changes in if you change your schema of the relational database, then you have to manually in your program change the object definitions for the objects that reflect the schemas in your database. So therefore we see a big push for object relational mappings from the industry. So in the Java world we'll see Hibernate. In the .NET world we see the Versant object-oriented database. Oracle is working with Java and the object-oriented model in Java, and we Lisp people have a thing called CL SQL. Now let's just look at the Java example. Yeah. If you go to the Hibernate website, then they provide an example of how to use Hibernate, and this is a very small part of their entire example where they define an event class. So what you have to do in Java is that you write all your methods that you normally would for an event, plus you specify in XML how your object maps to the relational database. And I won't go into detail. Please go to the Hibernate website if you want to see the Java example in detail. I just want to show you how we do the same example in Lisp. Yeah, and I'm running a little bit ahead of myself, but here's how we do it in Lisp. Yeah, it's slightly shorter and it's several times faster than the Java example. Yeah, so you can imagine that for our customers this is really important, that if you have many different classes, that you just can be a little bit briefer with the way how you define your object model. Let's ask the rhetorical question: is the object relational mapping a solution? Well, in principle, using a programming language object model with a relational database sounds good, but as I've shown you and I hopefully convinced you, it sounds like a good idea, but what you just saw in the previous example, it is a bit convoluted, and what we see from the literature is that it's not really scalable, and if you work with this object relational mapping for really large data sets, you get big performance hits. So that is why Franz decided to build a new object-oriented database that takes most of the programmer pain away. So in our solution called AllegroCache, we made sure that there's no distinction between the data and the language. Yeah, you saw our very simple example of a def class of an event. I mean, that's how simple it is. It's just an ordinary Lisp. For the programmer, it means there's no distinction between objects in memory or on disk. So you as a programmer can completely focus on your object model. Yeah, because we, or at least ACL, will take care of everything underneath it. We store the data for you in a kind of a pointer space, and we make sure that referential integrity is automatically maintained. So if you have an object that points to another object and this object gets deleted, then automatically everywhere in the database where there are objects that point to this object, that object is automatically set to nil. You don't have to worry about that. And then we present you with some techniques to do graph search and complex query inferencing and reasoning directly on the objects, and later I will say a little bit more about that. And in our system we can work with heterogeneous data from the ground up. You can take as the slot of an object any Lisp object. So it can be a small number, or it can be a large size string, or it can be an ordinary non-persistent object. Everything just will work automatically. And if you, during the development of your program, decide to change the class, you just redefine the class and everything will keep working for you automatically. Yeah, so that's a kind of a general overview of this AllegroCache. Now, AllegroCache is really a modern database system. So if you use AllegroCache, you can use it in standalone mode, and many of our customers use AllegroCache almost as an analytical tool, where you have one Lisp, you start AllegroCache in your Lisp, and then you read in large amounts of data and you do your reasoning. Yeah, you don't worry about that other people also will have to use it. You just use it as a private database. And then several of our customers use it in client-server mode, where you have one Lisp that runs AllegroCache, and then you have multiple clients that all can take to the same database in unlimited amount of connections. It's also modern in the sense that you have commit and rollback. So you work with your objects, and once you think that everything is safe, you do a commit, and then if AllegroCache accepts the database, the data is committed. If there's an error, if say someone else already changed the objects from beneath you, then you will get a rollback. Yes, so it's just like a normal database with commits and rollbacks. It's got all the features of an ACID database, the things that the modern databases have. I'm not going to explain what ACID is in this presentation, but I gave you a link where you can find a very clear explanation of what a modern database should provide. In our database we provide optimistic concurrency. So if you get objects in memory from the disk, then these objects are not locked in the database. Only when you write the objects back to disk, you will find out whether someone changed the objects. Yeah, this guarantees you the highest throughput of objects. However, if this is a problem for you, we can give you patterns of how to do object locking on the application level. Of course, like in any normal database, you can dump and restore your database. We dump and restore our databases using XML. All modern databases are implemented on top of B trees. Well, AllegroCache is also implemented on top of B trees. Initially we used LazyCat's Berkeley database. There were too many locking problems with that particular database, so now we use our own completely Lisp-based B-tree version, but mostly modeled after Berkeley database. And yes, it is a very powerful database. We can store billions of objects and terabytes of data. So this was a description of AllegroCache from a modern database perspective. What is AllegroCache for a Lisper? Well, it is basically just class but then persistent, and it will run on every 64 and 32-bit platform that we support. The beauty of having this all in Lisp is that you don't have to worry. If your Lisp runs on a particular platform, then AllegroCache will run on that platform. If you do a def class for a persistent object, then the definition of that class goes to the database itself, so later on you can do meta reasoning on your objects. One defining characteristic of an object-oriented database is that every object is unique for the lifetime of the database. So in our database every object has a unique ID. So in our database every object has a unique ID, And all our objects have a little bit of overhead because we store with every object the transaction number and the class version number. Because in our system we can, even if you're working with multiple clients, clients might change the objects while running, and so you need to store the class version number under which something was made, created or saved. And of course we can index on every slot in the database. But what more features do we have? Well, if you need an index not defined on a particular class, you can create maps. Basically you can look at them as persistent hash tables, and we'll give demos of them in our demo set. We have a thing called sets, which basically are persistent large collections of objects. The reason for that is that we store our objects basically as blobs, as binary blobs on disk. So if you say have an object with a long list of values, then adding objects to that list becomes more and more expensive. So that's why we created the set object, so that you get a constant time addition of sets to a collection of objects. So, and if you want to do more advanced stuff with indexes, you can use our native list B trees. They're very current because we support floating cursors, multiple concurrent readers. The keys and the values can be as big as you want them to be, although we have to say that our B trees are most efficient if you can cram the keys and the value in less than 32 bytes. But if your keys and the values are more than 4 gigabytes, we still store them in the B tree. You can write your own comparison functions in Lisp. So if you want to do some really complex indexing, you just write your comparison function in Lisp like you would do with a sort function. So how do you get data out of AllegroCache? Well, in the first place, you just can use Lisp. Lisp is the best language for graph search anyway. So with AllegroCache, if you want to do complex graph search, you just use Lisp itself, because you use Lisp to work on class objects, and the AllegroCache will make sure that you get your objects in memory when you need them. If you want a more declarative retrieval language like SQL, but with the power of a full programming language, then you can use our ACL Prolog. It's completely integrated with AllegroCache. And for people who are really familiar with SQL, we do have a full but experimental SQL support. So if people want to experiment with that, again, call us up and we'll send you the SQL version. And finally, we have full text search at Google speed with Google scalability. And for many of, if you work with heterogeneous data and your data are strings and the strings are mostly built up of natural language strings, then having this particular feature is extremely worthwhile. So we have already several customers that use the beta version of AllegroCache for applications and prototypes. I'm not really going into detail for these applications. For some of them you just can go to the website. I want to mention a few. One of them is BioBike. It's a project at Stanford run by Jeff Schrager. It's a bioinformatics project where he runs a complete frame system on top of AllegroCache, and this integration thing we now call the Knowledge Operating System, and I would urge you to go to their website and just see how AllegroCache is used for a real-world system. Another customer of us is Pepito. It's a Belgium customer that has integrated AllegroCache in their data mining application. And the third one I want to mention is Tellme, a telecommunications company here in California who uses AllegroCache to experiment with a personal directory for mobile phones. And for the rest, I'll just please go to the websites, or I'll do that later. So then, and finally, I think for most Lispers this was highly uninformative. Yeah, I just gave you an overview. You probably want to see it really in action. So please go to the demos provided on our website. Thank you.